All right, you're welcome back. My name is Victor Odigoma Oye. We are looking at linear inequality, and it is under algebraic processes. Under algebraic processes, these are the linear inequality symbols we are going to be deploying while handling inequality problems. Take, for instance, this is greater than, and this is less than. This is greater than or equal to, and this is less than or equal to. These arrows you are seeing here are the arrows that point to the direction where the solution set lies. That's when we solve an inequality problem, we will obtain a solution. Now, that solution lies in a given direction. So we use these arrows to point to that direction on the real number line where the solution set lies. I'm sure you understood that. Let me take it again. I said when we solve an inequality problem, the solution we obtain from that inequality problem will lie in a direction. It will lie in a direction. Now, these arrows is what we use to point to that direction on the real number line where that solution lies. Is that okay? So you can, one more thing is, you realize that these arrows, these two, the base is open. The implication is that that result you obtain is not inclusive in the solution set. Whereas in this case, when you obtain a result from an inequality, the closed base, if this is the symbol that is used in that inequality problem, then this base of the arrow pointing to the direction where the solution set lies will be closed, meaning that that result obtained is inclusive in the solution set of that inequality. I'm sure these symbols, my explanation in them is well taken. Let's move straight to some examples to buttress what I'm saying. If I have, let me take one on this. If I say that x is greater than say 2, x is greater than 2, it then means the solution I am talking about, the range of x I'm talking about, is bigger than 2. And I can show that on the real number line as, if this is my origin, maybe here 1, maybe here 2, then it then means I'll use this arrow to show the direction where the solution lies. So it then means that the value of x is greater than 2, meaning it is this. I will put it here. Now, can you see that this is open? The base of this arrow is open. The implication is that this 2 you are seeing here is not included in the solution set of x. I'm sure that is taken. This 2 is not included because the meaning of this is that x, the range of values of x, is bigger than 2. Then 2 is not inclusive in that set. I'm sure that is very, very clear. Okay, so we can represent it on the number line like this. Now, let me take the other one. If I say that x is, this is meaning less than, x is less than minus 1. You see on the number line, I can, if this is my origin, maybe somewhere here is minus 1. The positive values are over here. Then x is less than minus 1. It then means I will point the direction of the arrow this way. Can you see that? So all the values that are after minus 1 are the range of x. Do we get that? So x is less than minus 1 is represented on the number line like this. Let me take this. If I say x is greater than equal to, let's say, greater than equals to minus 3, then on the number line, I am going to put my origin, and let's say somewhere here is minus 3. Then I will use an arrow that has a shaded base to point the direction where the solution lies, as like this. Now, what is the meaning of this shaded base? the meaning is that this minus 3 is inclusive in the solution set of x. I'm sure that is very clear. Let's say the last one, if I say that, of course, you can see the role of all these symbols in explaining what we are doing. Of course, we are considering that you have finished solving that inequality problem, and it is very possible that these are the answers you have obtained, and there is need for you to put them, represent them, show them on the real number line. Please, we are going to be deploying this in the next 4 to 5 classes. We are still going to be, because this is the introductory part of it. We are going to progress into simple problems and then complex problems. Then we start solving WIEC examinable questions that come from inequality. All right. So please, you follow us. Now, what again was I looking at? Okay, let me consider the other one too. If I say x is less than or equals to, let's say half. So I can put it on the number line. Let's say here is my origin and somewhere here is 1. So here is half. Okay, so x is less than or equal to half. So the shaded base will indicate what we want to explain, and it will point this direction that x is less than half. So any value that is less than half or equal to half, less than or equal to half, will be long to the solution set of x. So I'm thinking that the explanation I have given, okay, in these inequality symbols are well understood. The next thing we are going to do now is we are going to bring in problems. We are going to bring in problems that require us to solve a given situation, solve a given inequality problem, and possibly represent it on the number line. Okay, you stay with me in the next class. I am Victor Odigoma Ohia. Please subscribe to this channel and share to your friends, and okay, click also on the notification button so that you'll be notified as soon as we make our uploads. Thank you.